Hello students, in this chapter logic, in the previous module you learned what is logical equivalence, right? But now in this module you are going to advance your knowledge. You are going to learn about sums which are based on logical equivalence. So ready for it? Yes, here we start. Here the sum given to you is, using truth table you need to verify that whether the statement patterns are logically equivalent. Yes class, and what is the statement pattern given to you? Negation of P implies negation Q, which should be logical equivalent to P and negation of negation Q, which should also be logically equivalent to P and Q. Okay class, so here comes the statement pattern in front of you. Now how do you construct the truth table for it? So here we learn. So class, first of all you need to count the number of statements and connectives for the first statement pattern. And which is your first statement pattern class? Negation of P implies negation Q. So first you have to catch that statement pattern and you have to count the number of statements and connectives. So how many statements do we have here? 2. And how many connectives do we have here? 3. Yes. So in all we need 5 columns for the first statement pattern. So here comes the truth table, where first column will be P, next column will be Q, next column should be, yes, for that you have to wait. First you have to put the truth values for PQ. For P you will write true, true, then false, false, while for Q you will write true, false, true, false. Now you will move for which column? Yes, negation. P implies negation Q. For that, first you require the column for negation Q. Yes class. So negation Q. What is the rule? That negation of true gives you false and negation of false gives you true. So you will try to get the negation of column Q. So for true you will write false. For false you will write true. Again for true you will write false, and for false you will write true. Now you have the truth value for P. Yes. Do you have the truth value for negation Q? Yes. So you have to move for P implies negation Q. Understood? This is all you have learned in the previous modules of truth table. Remember? So that's what we are applying here. P implies negation Q. For that you have to catch which 2 columns? P. Next one is negation Q. And what is the rule class? Implication. And what does it say? True to false gives you false. Else true. So class, you have to find true to false combination, and that's for the first combination. So it will give you false, while for the rest of the cases it will be true. Yes class. Now you have the truth values for P implies negation Q. So now you can go for its negation. That is negation of P implies negation Q. You have to simply get the negation of this column, which gives you as true, false, false, false. So you have got the truth values for it. Yes class. Now we have completed our first statement pattern. Now we have to move for the next statement pattern. And which is the next statement pattern class? P and negation of negation Q. Now for that you have how many connectives? You have to simply count the number of connectives. Now you will ask, why not statements? Because the statements are same, which are PQ, and you have already got the column for PQ in this truth table, right? So you won't count the number of statements. You will only go for the connectives. So here the number of connectives are 3. That is and, then negation, and then again a negation. So you have 3 connectives, and that simply says 3 columns. But class, if you start with negation Q, do you already have a column for negation Q here? Yes. So do you need to repeat it again? No, not at all. So you'll directly go for negation of negation Q. Yes class. For negation of negation Q, you will try to get the negation of negation Q column. That simply gives you true, false, true, false. So now do you have the truth value for negation of negation Q ready? Yes. Do you have the truth value for P ready? Yes. And that simply says we can go for our statement pattern, which is P and negation of negation Q. So now we'll take both the columns. And which rule we need to apply? Conjunction. And what does conjunction say class? True and true gives you true, else false. So which combination do you find here? True and true. And you'll put for true and true as true, while for the rest of the combinations you will put false. Okay class. Now we have completed the second statement pattern as well. Now we move to the third one. And which is the third one class? P and Q. Again you will count the number of connectors. How many connectors do we have here? Only one, and that means only one column will be added, which is P and Q. Understood? So P and Q, you have to catch only those two columns. Which two columns? P and Q. And you have to get and rule, which is true and true, which gives you true. While for the rest of the cases it should be false. So what do you find here? You will go for all the three statement pattern columns here. That is, negation of P implies negation Q, P and negation of negation Q, P and Q. What do you find? Do you find that all the three columns are having identical truth values? That is true, then false, false, false. And that simply says that yes, the given statements are equivalent. Yes class, here all the three statements are logically equivalent because they are having identical truth values in their column. So this is how we learned to get the truth table or to verify the statement patterns to be equivalent with the help of truth table. Yes class, we'll advance our knowledge in this in the next modules. Till then, thank you.